As I mentioned before, programs are always changing. Or put it this way, if you're fortunate enough to design a program that other people really want to use, they're going to want you to change it. They're going to want you to make it better and better and better. In this video, what I'm going to do is make a change to the CAT program, give it some better functionality. And what you're going to see is that that careful design that we did is going to help make that change easy to manage. What we'll do is we'll run the change right through the whole recipe, starting with the analysis and then going on to the code. We've got our CAT program, and we can run it, as we saw, by saying main of 0, where 0 is the initial state of the world. But there's something about this CAT program I don't really like, which is the CAT is moving a little bit too slowly. I just don't have time to wait for it to get there. So let's see about revising the program to make the CAT move more quickly. As I mentioned in the last video, if we think about this program and we think about the analysis that we started with, one of the things we worked very hard to do was to make sure there was a clear correspondence between the analysis and the program. So the constants in the program correspond to what we identified in the analysis. The data definitions in the program represent the changing information that we identified in the analysis. The Big Bang in the program has the Big Bang options identified in the analysis, and the handler functions play their roles with respect to the changing information and the interaction with Big Bang. The fact that we've kept this clear correspondence between the program and the analysis means that we can use the analysis as a kind of abbreviation, or the technical term would be a model of the program. We can think about what we need to do to the program by starting doing it with the analysis. So let's do that. The problem we have is that the CAT's moving too slowly. In some sense, what happened here, when I look back at the analysis, is we can say, hey, the CAT's speed was an unidentified constant. There is this constant called the CAT's speed. The CAT's moving 1 pixel per clock tick. If we identify that as a constant, so if we add speed to the analysis here, then we're going to have an opportunity to change that speed to something more than 1. And if we use the speed over here in the on-tick handler function, then changing that constant value will control the speed of the CAT. So now that we've updated the analysis, let's just go through and do it to the program. Well, the first thing is there needs to be a speed constant. So I'll go right here and I'll add the constant speed. And 1 was too slow, so let's say 3. The great thing about it being constant like this is if we think later that 3 is not enough, we can change it again. So I've checked off this part of the analysis where I was supposed to add the speed constant. And in the notes I made on the analysis, it says I also need to go look at the on-tick handler. So I scroll down here to Big Bang, and the on-tick handler is called Advanced CAT. And if this was a big program, then I'll show you Racket has a tool I can use, which is I click Check Syntax, I click Write on Advanced CAT, and I can jump to the definition of Advanced CAT. Now, it wasn't a big program, so I didn't need that help. But if it was a big program, that would help. Another way to do it is you can go right up here and search through all the definitions. Jump right to Advanced CAT. Now I'm going to quickly replay the How to Design Functions recipe with this new constant in mind. The signature doesn't change, the purpose changes. We're going to produce the next CAT by advancing it speed pixels to the right. So let's see, the stub didn't change. The check expects changed. Now this is, instead of being Advanced CAT 3 produces 4, this should be Advanced CAT of 3. Now you might be tempted to put a 6 here, but that's not what I'm going to put here. I'm going to put +3 speed. That way, when I go change the speed constant, this check expect will automatically be the right thing. And this way, this check expect really corresponds to the purpose. It says whatever the speed constant happens to be, that's how much we're supposed to advance the CAT by. So let's see, advanced cat, the template doesn't change. Here's the body of the function, and this 1 just becomes speed. I can run my test pass, and now I can say main of 0, and I have a speedier cat. So the important thing to take away from this video is programs always change. I said that before. Programs always change because people want them to be better all the time. And so that means we want it to be easy to change programs. And in the case of these world programs where we have this analysis, working hard to make the structure of the program match the structure of the analysis made it really easy to go back and make this change, because the analysis became kind of a model of the program, and we could think about what we needed to do to the program first at the model level, first using this analysis picture, and then quickly run through the program, catching it up to the new analysis. This ability to work on programs by reasoning about them at a model level is one of the things that really separates program designers from people who write code that just happens to work. And we're going to talk about it a lot more in the course as we go forward.